All right, so a motorboat can go 8 miles downstream on a river in 20 minutes. We can calculate the speed in miles per hour from that, and we're going to want to do that. It takes 30 minutes for the boat to go upstream the same 8 miles. So find the speed of the current. So there's a couple of things we're going to do. The first thing that we're going to do is this into miles per hour. So if we say for the first bit of this, and I'll just choose a different color for each part of it, it can go 8 miles downstream. That's going with the river. We say 8 miles in 20 minutes equals how many miles in 60 minutes? And 60 minutes is going to be an hour. So we can then write that in miles per hour. Okay? So there's a couple of ways you can do it. You can multiply it like the proportions. You can do cross product, that times that equals that times that, and get 20x equals 8 times 60, or 20x equals 480. Dividing both sides by 20, we get x equals, how do we do this? One way that you can do it is to cancel, first divide both by 10, and now you're really just doing 48 divided by 2, and that's easy. 48 divided by 2 is 24. Okay? Um, so basically what we say is so up on top it's saying that you go 24 miles in 60 minutes, or 24 miles in 60 minutes is 1 hour. 1 hour, that is 24 miles per hour. Hope you can see that that's true. Okay, with the river, going along downstream. Now, how do we do this other bit? Well, we want to do the same thing. We want to take what we know. Let's see, you're going the same distance, you're going 8 miles, but now it's taking you 30 minutes to do it because you're coming upstream and you're fighting the current. So what is that in 60 minutes? What's the rate of speed at 60 minutes? Well, that would be, you'd go at that same speed, 8 miles in 30 minutes would be how many miles in 60 minutes? You might be able to do this in your head, but essentially we're doing the cross products property, and we get 30x is equal to 8 times 60 again. So 30x equals 480. But now we're dividing both sides by 30 instead of 20 like we did on the other side. And you get x equals, once again, we need to simplify this, and we can multiply top and bottom by 10 to get 48 over 3. And what is that when you divide? It actually works out to be 16. Okay, so that's 16 miles for every 60 minutes, or 16 miles for every 1 hour, which equals 16 miles per hour. Okay, so going downstream, we're going 24 miles per hour, and upstream, we're going 16 miles per hour. So I'm gonna do a little trick here. Okay, it's not really a math trick. It's kind of a trick for the technology that I'm using right here, which is to grab, I don't know if I can do it, grab the actual problem here, and it'll copy it for me, because then what I can do is, oops, sorry about that. What I can do is bring that down. What I'm going to do is move this whole thing up and continue working on the problem. Excuse me. Okay, so that I have more room to do the math. So this is going to be a system of equations. Okay, we've now found that going down the river, again, to reiterate, we went 8 miles in 20 minutes downriver. That's 24 miles an hour to do that. And we went 8 miles in 30 minutes coming back up the river. That's 16 miles per hour. So we want to write a system of equations. And what we're going to write is we need to make a variable that is let x equal the speed of the boat. And let y equal the speed of the river, or you can also, like the river, you can call it the current. So speed of the current, because that's the word that they're using when they say find the speed of the current. Okay, so speed of the current means the speed that the river is going. All right. Well, excuse me. When we were going downstream, we said the speed of the boat and the speed of the river add to each other. And what was that speed when you're going downriver? It was 24 miles per hour. But if you're going upstream, obviously the boat is going faster or you wouldn't be able to get upstream. But we say the speed of the boat, take away the speed of the river because now you're fighting against it, gives you a slower speed of 16. Okay? System of equations. We can now solve this. We can say, let's add these together. X plus x, 2x, y minus y, that cancels out, and 24 plus 16 equals 40. Okay, dividing both sides by 2, x equals 20. What does x represent? X represents, and we'll write it over here, 20 miles per hour. The speed of the boat is 20 miles per hour. That's not what they're asking for, though. They're asking for the speed of the current. So we already know what x is, and we can plug it back into one of our equations. We can say, let's pick x plus y equals 24. And if x is 20, then we simply need to subtract that 20 away, and we get y equals 4. So we can then say down here on the bottom, speed of the current is 4 miles per hour. Done. A little bit of a tricky problem, but I think that these are interesting problems. The level of complexity is actually a fun thing to think about, I believe, because again, let's going back and just examining it for a second. Okay, they're giving us some amount of time it takes a boat to go a certain distance, and if you know the distance that you go and the amount of time it takes you, you can calculate that as a rate of speed, right? How fast are you going? And again, as we did that, we found out that downriver, where you add your speed, the speed of your boat, to the speed of the current, was 24 miles per hour. Okay, subtracting them because you're fighting against the current is 16 miles per hour, and then saying, okay, now that we know that, we write our system of equations knowing that the rate of speed that we're moving and saying, and the, not the rate of speed rather, but the amount of time that it takes us in each direction. And then we can say, okay, from that, we can calculate the two different speeds, the speed of the boat and speed of the current, from the fact that adding those amounts together would give us 24 miles an hour and subtracting those amounts would give us 16 miles an hour. I like it. It's a cool problem. I think that for those of you that enjoy actually applying math to real world situations, this is kind of a fun and interesting way of dealing with speeds and dealing with these kinds of things. Fun.